Here's an example from the homework for section 4.3. In this problem, you're given a polynomial, which I've copied down up here in case you're having trouble with my handwriting. It's x cubed minus 8x squared plus 37x minus 50. And we're told that 2 is a zero of this polynomial. We're tasked with finding all of the remaining zeros. Since we notice that this polynomial has degree 3, there are up to 3 distinct zeros. It's possible that 2 might be a zero of multiplicity 2, which means the factorization of p of x has x minus 2 squared, and then some other factor. So maybe we only have one other distinct zero. But the way to figure this out is take the fact that 2 is a zero of the polynomial p of x, and from the factor theorem then, we're guaranteed that x minus 2, fix that, x minus 2 is a factor of p of x. This is supposed to say factor. Sorry about that. Okay, so that means that the polynomial p of x can be written as x minus 2. If I write more slowly, I've discovered this tablet cooperates a little better. X minus 2 times some other factor. Since we see that the leading term in this polynomial up above is x cubed, I know this is a quadratic factor here. Once I pull out x minus 2, so pull out that linear factor, we'll have x squared plus whatever over here. But so the question is, how do we find this missing factor right here? This is supposed to be a question mark. Dead burn it. I want that to actually look like a question mark. So help me. There we go. Okay, question mark. To find this missing factor right here, this quadratic factor, I want to isolate it. So I can do that by dividing by x minus 2. That's why when we're given a zero of a polynomial, we go straight to synthetic division. And the reason we do that is so we can divide out the corresponding factor and solve for, looking for my little pointer, and solve for this missing factor here. Okay, so I'm going to go for that synthetic division. So I'm dividing out x minus 2. The coefficients from p of x are 1, and then negative 8, and then 37, and then negative 50. I'll get the negative in front of this. Okay. Skip a line and draw a line. Let me bump this up. Okay, so I bring the 1 straight down. 2 times 1 is 2. Oh boy. Try that again. There we go. Add these values. So this is negative 6. 2 times negative 6 is negative 12. Add these, we get 25. Oh, geez. Okay, 2 times 25 is 50. Add these, we get 0, which we need to get 0 there. That means the remainder is 0, which confirms, yes, x minus 2 is a factor, which then confirms, yes, 2 is a zero of this polynomial. Okay, but what we also get is these are going to be now the coefficients for this missing factor right here. So I'm going to slide the screen this way now. Now we know that this p of x can be expressed as x minus 2, which we just divided out, times, let me give myself some more room, from the division x squared minus 6x plus 25. Oops. Plus 25 right here. Okay. And again, so the overall task here is to find all the zeros. So we want to solve, okay, this thing equals 0. So if we set x minus 2 equal to 0, then we get x equals 2. Not all that exciting since just the instructions for the problem told us that 2 is a 0. But so now we can focus on this other factor. We can dismiss the x minus 2 factor. We're done with that. And focus on solutions to x squared minus 6x plus 25 equals 0. So 25 and 6, I mean, those are nice numbers. We feel like this should be factorable. I should be able to handle this. But there are not two numbers that you can multiply to get 25 and add to get negative 6, right? With 25, your only options are 25 times 1, which we're not making 6 out of that, or 5 times 5. We're not making 6 out of that. So plan B is use the quadratic formula. So x equals opposite of b, which would be positive 6, plus or minus, this is a 6 and not a b, believe it or not, the square root of b squared, which would be 36, minus 4 times a times c, which to avoid having to write too much, because you can see how that goes, let's talk this out. So that's 4 times a, which is 1, so now we're at 4, times c, which is 25. So 4 times 25, that's 100, divided by 2a, which a is 1 in this case, so that's just 2. So we have 6 plus or minus the square root of 36 minus 100 is negative 64, all over 2. The square root of negative 64 right here is, first of all, imaginary, because it's the square root of a negative number, so it's going to have an I attached. And then square root of 64 is 8. So the square root of negative 64 is 8i. So I'm going to slide this down. So we have 6 plus or minus 8i divided by 2. Now divide both parts by 2. So this is 3 plus or minus 4i. These are the two remaining zeros. In my math lab, you're going to have to list them out separately. So just to warn you, so you'll input 3 plus 4i. Oops, this is an I, sorry. And 3 minus 4i.